Astronomers are proving there's strength in numbers. By linking several medium-sized telescopes together, they can get as much power as they would from a single gigantic one. CNN's Don Harrison explains.
For centuries, astronomers have made each new generation of telescopes bigger than its predecessor in order to gather more light and see farther into the expanse of the universe. But there are physical and practical limitations to the size of a single mirror telescope, and this has led to the development of innovative and revolutionary designs that combine the light from several telescopes. This approach is called long baseline interferometry.
Interferometry combines light from one telescope and another telescope, brings it to the same point so that you get very high resolution.
By linking together several telescopes at multiple locations, astronomers can see as much detail as with a single huge telescope of the same size. This technique has previously been limited to radio astronomy, but is now being used with optical and infrared telescopes.
By spraying these mirrors out over a large area on the ground here, we can actually make telescopes that have sizes on the order of, say, on the order of kilometers.
Currently, there are 8 optical and infrared interferometers online. And of these, the Mark III long baseline optical interferometer on Mount Wilson in California is one of only 2 turning out useful data. The Mark III interferometer collects light with 2 12-inch telescopes along a variable baseline from 4 to 31 meters. An auto-guiding system is used to keep both telescopes focused on the same object.
When actually we'll be able to see detail better with this telescope, of the bright features that one could actually see with a single telescope.
On a night with good visibility, technicians can observe about 200 stars for about 75 seconds each.
And now we can go to the next star.
The data is stored on magnetic tape and then taken to the Naval Research Lab and the Jet Propulsion Lab for analysis. The Mount Wilson Array has been able to measure the diameters of stars, the orbits and masses of binary stars, and the atmospheres of variable stars. Dr. Mike Schau, head of optical interferometry at JPL, says interferometry will eventually provide views greater than the Hubble Space Telescope, even after it's repaired.
Ultimately, of course, what we want to do is to measure distances to the furthest objects and basically determine the size of the universe.
There are 5 major interferometers currently under construction and 5 in various stages of planning, with several nations providing research and resources. One of the largest ground-based interferometers planned will include the Keck 10-meter telescope, currently the largest in the world. A second 10-meter telescope will be built, and 4 auxiliary telescopes will be added to form the Keck Interferometric Array. And among future designs already in the planning stage are various space-based telescope arrays and lunar-based interferometers. By completely eliminating the distorting effects caused by atmospheric turbulence, astronomers will be able to view 12 to 15 billion years of cosmic evolution. These new celestial vistas that interferometry represents could answer fundamental questions about the origins of the universe, or even bring to light extraordinary new phenomena.
When we come back, why many lemur species are threatened with extinction. And if you'd like to order a transcript of our show, the number to call is 303-831-9000. We'll be right back.
July 1976. The United States celebrated its bicentennial. Jimmy Carter won the Democratic presidential nomination, and NASA's Viking spacecraft made the first landing on Mars. CNN's Dan Blackburn looks at the history and the future of Mars exploration.
And there's the first piece of information coming in.
As the first image of Mars appeared on the screens at the Jet Propulsion Laboratory in the summer of '76, years of work and dreams and hours of tension hit their peak.
Oh, that's beautiful.
I was absolutely overwhelmed, tears running down my cheeks. I hugged everybody I could find.
The Viking lander was on the surface of Mars, safely touching down on a potentially hazardous terrain. In fact, the landing was delayed by several days because the initial landing site was considered too risky.
We didn't know where the rocks were. We didn't know what was smooth or rough. And there was just a thrill of exploration, I guess, that I'll never forget.
Until the mid-60s, many people thought Mars was crisscrossed with canals full of water linking possible centers of civilization. Those theories collapsed in 1965 when the Mariner 4 spacecraft flew past the red planet and sent back the first photos showing a desolate, barren surface. But it was the dramatic arrival of the two Viking landers in July and August of 1976 that really brought Mars home to an Earthbound audience. What they found was a rocky, reddish, dusty planet with bitter cold temperatures, enormous volcanoes accompanied by sweeping lava flows, and canyons far deeper than any on Earth. But much to the dismay of scientists, there was no sign of life.
It was a big disappointment and somewhat of a shock, because not only we didn't find anything living in the two locations, we also really couldn't find any organic material on the surface.
Most experts believe Mars once had running water, lakes, storms, and a viable atmosphere that might have supported life. But by the time Viking arrived, only hints remained.
As Mars began to dry up, as the atmosphere became less able to support liquid water, perhaps those creatures got caught in the crevices between the water ice polar caps of Mars that recede and expand each year, and that is the place that you might find some life today. Most likely, though, no life on Mars.
The real question now is, was there life there once? Because the origins of Mars probably was similar in many ways to the origins of the Earth. Life formed on Earth, it may have formed on Mars.
And there have been hopes for a manned journey to Mars sometime in the next century to follow in Viking's footsteps and answer that question. The Viking mission to Mars was one of the biggest successes in NASA's history, but the agency has been slow to follow up. The two landers safely reached the surface of Mars, and scientists could have sent a third spacecraft.
We could have flown a third Viking in a 2 to 4 year time period for something in the order of $150 or $200 million. But that program, unfortunately, was not pursued.
Next year, the United States finally will launch the unmanned Mars Observer to map the red planet's surface for possible future landings. The Soviets will follow with their own small surface probes in 1994. And 2 years later, they plan a multinational venture using a Mars rover and a specially designed balloon, which would drift over the surface as a wind-blown surveyor.
The balloon offers one way of doing that because it can fly in the Martian wind and yet at low altitude to take pictures. And the rover offers another way, which you can actually put instruments on the surface and do sampling there.
President Bush and NASA officials have targeted the second decade of the next century for putting men on Mars.
For the new century, back to the moon, back to the future, and this time back to stay. And then a journey into tomorrow, a journey to another planet, a manned mission to Mars.
A presidential commission envisions using the proposed space station, or the moon, as the base for launching a manned Martian mission. Virtually everyone agrees men must go someday.
You need field geologists to go in and look at selectively pick up samples, and a lot of this a robot can't do.
Some experts think the best bet is a combined U.S.-Soviet effort.
The fact of the matter is there's a lot of joint benefit, if we're going to Mars, to share some of the steps together.
But the Bush administration has been cool to that idea, and critics see the prospects for sending men to Mars receding.
We have the capability to do it, and it is realistic for us to undertake it. But the political will, the idea that humans exploring other planets should be the goal of our space program, that seems to have been lost.
Or at least under cautious review.
Still, future U.S. space exploration survived another challenge this week when the Senate defeated a budget amendment that would have slashed funding for the space station. When we come back, some of the best science lessons take place far from the classroom. We'll show you one at the beach. And by the way, if you want to order a transcript of this program, you can call 1-212-227-READ. We'll be right back.
You know, most people don't want to live next door to a nuclear reactor, and putting reactors into space may seem like asking for trouble. Plans for nuclear rockets include a lot of safety measures, but as CNN's Eric Gershon reports, some experts are still concerned.
The year is 2018, and a manned mission to Mars is just beginning.
If I'm going to Mars, the first thing I'm going to need to do is assemble my manned vehicle in low Earth orbits, some orbit around where the shuttle goes.
The spacecraft could not be launched from Earth because its nuclear engine produces radioactive exhaust. The major components include a Mars landing craft, crew and payload modules, propellant tanks, and a nuclear rocket engine.
A reactor that would be used on a typical defense mission might be about as big as a 15-gallon oil drum in diameter and about 12 feet high, and develop 2 gigawatts of power.
Once everything is ready, astronauts ride the space shuttle up, transfer to the Mars craft, and with one big burst from its nuclear engine, they're on the way. It sounds easy, but there are obstacles, including how to build and safely test a nuclear rocket on the ground. As many as 20 nuclear engines were tested in Nevada in the 1960s. That program provides a lesson in what not to do.
Effluent from the reactor was simply discharged into the atmosphere. We know that we can't do that today. We know there were some fission fragments, there were some radioactive particles in that exhaust, and we know that we're going to have to collect that exhaust.
Any test will most likely take place underground or inside a containment building. Once a nuclear rocket is ready for flight tests, it will have to be boosted into space. Scientists say safety at the launch pad is not a concern because reactors of this type are not dangerous until they're switched on.
They have uranium, but it's in the form of uranium-235. Until you run the reactor, it is not radioactive.
The hot reactor could be a problem when the spacecraft returns to Earth orbit.
You don't want a hot reactor coming back into the Earth's atmosphere. That would be quite dangerous.
The danger exists in the possibility of a spacecraft malfunction. A Soviet reactor did fall into an uninhabited region of Canada in 1978. It spread debris over a large area, but luckily no one was hurt.
We have argued that reactors should not be operated in Earth orbit at all. They should only be used in deep space missions, and then the question of disposal from orbit doesn't arise at all.
New designs provide boosters to push a reactor into high orbit in case of malfunction. This is also a way to dispose of a used reactor. If the orbit is high enough, it would take the reactor hundreds or thousands of years to fall back to Earth, by which time its radiation would have decayed to safe levels.